Alright, algebra kids. Guess what? We're doing graphing relations. Alright, so there's two types of graphs. There's continuous and there's discrete. Let's talk about continuous. Continuous points are connected by lines and curves. So, they're the little points. You see the little points right here? Phew, phew, phew. They're connected by this line, this black line that's right here. That makes it continuous because it connects all the values between here and here. And there's an infinite amount of numbers between those 2 points. So that's why it's considered continuous. Now let's check out discrete. Discrete means that you have distinct points, not connected by a line or a curve. So like right here, you see there's no line over there? They're all just distinct points. So that's why it's called discrete. Alright, here's some continuous examples. Continuous examples, the reason why I'm showing you this is because there's several different forms. This one's considered continuous because between here and here, there's a continuous or an infinite amount of numbers, and it shows a line. There's 2 dots that are connected by a line, so it's continuous. This one's obviously continuous. Even though this one's a curve, it's continuous. And even though this is one little bitty line segment, it's still continuous. Alright, now we didn't go over discrete because discrete's just points on a graph. So if you ever see just points on a graph, that's discrete. Here's some key words in graphing relationships you have to remember. Was constant means you have a horizontal line. Now horizontal means like this. That's horizontal. Alright. Rose steadily means it slightly goes up. So it's slanting upwards. So we're looking at something like this. That's rising steadily. Now stayed the same is another horizontal line. And then drop sharply means it's slanting downwards like this. So those are some key words that are usually used in graphing these relationships. Now you see this section right here? It's not supposed to be on here. So just ignore it. Alright, let's go on to our first example. It says sketch a graph for each situation. Tell whether the graph is continuous or discrete. So let's read it. Simon is selling candles to raise money for the school dance. For each candle he sells, the school will get $2.50. He has 10 candles that he can sell. So what we're going to do is we're going to graph a line or maybe just dots that represent this situation. So here's my graph. Alright, here's my graph. Now I set it up where X is my candles, so that represents how many candles I have. And the reason why I picked that to be X is because if I sell one candle, it tells me how much money I'm going to get. I can't get money and then tell me how many candles. So I have to sell candles before I get money. So this is called my independent variable. Or my input. Now this is considered my output or my dependent variable. Alright, so Simon sells one candle. How much money is that? It's $2.50. So it's right there. Alright, then he sells 2 candles. So he gets $5. And then $7.50. $10, and you can see a trend. Start making a trend all the way up. Now these dots don't quite line up, but you can see the trend. Now he can't sell 1.5 candles. He's not going to like walk up to some dude and say, hey, you want a candle? Here's half of one, and cut it in half and give it to him. That wouldn't make sense. The guy might be kind of upset that he cut his candle. So here we have a discrete graph. So this is discrete. And the reason why is because it doesn't include all these numbers in between the points, because you can't have half a candle or 3/4 of a candle or anything like that. You only can buy one candle at a time. Let's go on to the next one. Here it says Angelique's heart rate is being monitored while she exercises on a treadmill. While walking, her heart rate remains the same. As she increases her pace, her heart rate rises at a steady rate. When she begins to run, her heart rate increases more rapidly and then remains high while she runs. As she decreases her pace, her heart rate slows down and returns her to her normal rate. So let's go ahead and talk about if it's discrete or continuous. Discrete means you have specific points. Now, is her heart rate going to go from one point to the other point all of a sudden? So like is it going to go from like 64 to 60 without any numbers in between? No. Alright, so we know it's got to be continuous because her heart rate can't jump from one point to the other point without going through some other numbers. So it's going to be continuous. Now we actually have to draw it. So let's reread it. Angelique's heart rate is being monitored while she exercises on a treadmill. While walking, her heart rate remains the same. So instead of start out at 0, so let's start about right here. So she's walking. As she increases her pace, her heart rate rises steady rate. So we're going to slant up. When she begins to run, her heart rate increases more rapidly. So look at it increasing more rapidly. And then remains high while she runs. So it stays the same while she's running. As she decreases her pace, her heart rate slows down and returns back down to the normal rate. Right there. And you see, that's how you draw a continuous graph based on the story. So let's go on to the last example. Actually, second to the last example. This one says both graphs show a relationship about a child going down a slide. Graph A represents a child's distance from the ground. So actually this is kind of like the actual slide. Here's the slide. And here's the ladder to get up there. So here's the actual slide. It's the distance the child is from the ground. Alright, so you can kind of see the shape of the slide. So now let's look at the speed. The speed, as it's going down this way, increases because they're going down pretty fast. So, increases. But then you see there's a dip in the slide. So that shows this little hump right here where it gets stagnant and then goes down again. Because they decrease their slide. Their speed. So let's look at this last one. Here we want to actually write a story about this graph. You see it says water level and then time. So let me make something up here. Let's say it's raining. It's raining. Pretty heavily. And then it just kind of stops for a while. Stops raining. There you go. And then, after it stopped raining, somebody built a gutter so the rain would flow out of the yard. So, built a gutter. So, water would flow off the yard. So, that kind of shows you what the water level was in somebody else's yard. So that's kind of what I'm going for here, something that you can basically tell the story of what the graph is showing. All right, guys, that's the end.